My name is Isaac and this is Ian, and we're going to speak today about VoIP botnets, a topic which is very popular nowadays, all the VoIP, getting into more corporates and companies. Not always people understand the risk involved with implementing VoIP and the controller associated with that. So this is kind of our research into the area to see what can be done using the VoIP capability. It's not for a specific protocol, it's not for SIP or Skype, but it could be leveraged either. And we're going to show some demos of how we can do stuff over VoIP, and it's going to be very cool. So, yeah.
All right, let's kick this one off. VoIP. Intro to VoIP. This is not an intro to VoIP talk. You're going to hear my heartbeat. Can you hear me now? All right. Shit. Heard that. All right, so we're not going to do an intro to VoIP. VoIP is everywhere. We've got tons of residential VoIP providers such as Skype, Avage, Phone.com, Uma. They pop up like mushrooms after the rain. Obviously, in corporations, it's really de facto standard. All the internal communications for every company that I walk into today is voice over IP. Cisco's, the Avaya's, the Alcatel-Lucent, whatever. It's a vendor fest out there. And it just works. Now, one of the biggest problems of voice over IP is that it works so well. Okay? You get a vendor in, he drops a box, turns it on, and it works. You start plugging extensions, having fun, conference calls, trunks, everything's very easy. Even the free stuff, like Asterisk. Okay, you just download a VM, it's already made, everything's installed. If you have a Digium card, recognizes it, trunk it out, and get a SIP provider, or just a plain old PSTN. That's the biggest problem of voice over IP in our view, because that basic configuration is just not good enough. No one takes care to actually fully utilize the capabilities that voice over IP provides you in terms of security. We're not saying that voice over IP is really fucked up. It's just kind of, and people just don't care because it just works. SIP is the protocol that we like to play around with. Anyone here that doesn't know how HTTP works? Get out. All right, so if you know HTTP, you basically know SIP. All right, it's a request response protocol. Forget the fancy graphics behind me. It's really simple. If you want to, again, read more about it, Google it, because this is not an intro to SIP talk either. So what's new with voice over IP and security? Let's dig in. We're going to talk about two issues or two areas of research that we've been digging into. First one is voice over IP as a getaway car. We'll see some interesting techniques that relate more to data exfiltration and back channels, and see how voice over IP can be utilized to do that and how people are doing that. And the second topic, which is really cool, is voice over IP botnets. We're going to see how voice over IP can be used as a command control channel to message between a bot master and a lot of bots. So let's start off with a getaway car. So voice over IP can traverse firewalls very easily, right? That's by design. It can pierce NATs, it can go over PSTN if you're in a confined environment, let's say, of a very secure network that doesn't have an internet connection, but has a VoIP network on top of it. There is some PSTN line that allows that voice over IP network to go out and make calls and receive calls from the outside world. And on top of that, no one really looks at voice over IP. Okay? You're really looking hard at your web traffic and email traffic because you've learned that all the bad stuff is there. Okay? That's where all the lulls are. Voice over IP is kind of just works. which means you can exfiltrate. Okay? You don't have to go through the hoops of transcoding your data and modifying it and encrypting it and trying to hide it and kind of sift it, drip it a little bit by bit to avoid pesky stuff like DLP and stuff like that. You can just use voice over IP to push the data out. Second topic, voice botnets. We're kind of rushing through this to get to the meaty stuff. And also because the demo is really prone not to work. It worked, what, twice at the office? Yeah. That was like 6 months ago? Yeah, okay. Yeah, it bailed on us at B-side, so we're really hoping, and we gave it at a church there. So all our prayers weren't answered, so hopefully this is going to be a little better. So voice over IP botnet. Basically take your good old standard botnet, disconnect all command control channels. Okay? All the bot hunters these days look for specific communication. They look for IRC, for HTTP. They're looking for specific domains that host all those command control servers, and they're doing a phenomenal job. I know that. I'm dealing with that on a daily basis sometimes. So disconnect all those command control channels that everyone is looking at and replace with VoIP. Okay, simple so far, everyone on the same page. And, you know, you get a command control channel that's fully mobilized. Net piercing, no problems in terms of, you know, running through different networks. It looks really legit. Okay, because it's voice over IP traffic, and we've established that no one really looks at voice over IP traffic. And worst come to worst, you'll see some phone calls coming in and out, and some discussions or sounds going over those phone calls if you really care to listen up to them. And it's really harder to pick into. Again, if you do start looking at the actual communication, you need to start deciphering what's going on over RTP and other streaming H323, whatever, and start buffering it, decoding it, figuring out what the hell is going on there, because we're not talking about actual data, we're talking about sound. So this is all streamed. Well, everyone actually needs a voice botnet. When we look at what is being done right now from the criminal side of things, most of the work is focused on establishing secure channels, back channels, stuff that's not going to break, peer-to-peer communication, so that when my one point of failure fails, my botnet doesn't just disappear from the face of the earth. The botmaster is literally more mobile using a voice over IP channel, because you can actually walk around with a cell phone or pop into some phone booth, dial a number, and connect to your botnet and issue commands. Okay, so it really detaches the botmasters, the bad guys, from their laptops and their command and control servers. They can come to Vegas. It's much more anonymous. What we're demoing and what we're looking at is command control servers that are actually conference call numbers. You can get conference call numbers for free. No identification, no nothing. You can set up your own pretty easily. Right? I mentioned Asterisk before, phenomenal. Right? And it's all ready. Just pop a VM, not pop a VM, like take a VM and put it somewhere, use it, and you have a SIP communication readily made. And if you really want to go through trouble, you can actually get a real phone number, cost you a couple of bucks a month, and switch that straight back to the conference call number. And you can actually transfer fair amounts of data in and out. If you guys remember, I know I do, good old modem days, it's actually pretty fast. All right? Especially if you're trying to just send a few commands and get some status, not, you know, dox someone's 20 gigs of whatever. And it is starting to show up as an alternative method of communication. We're seeing that already. So anyone who nods too vigorously right now, someone can grab him and take him to spot the Fed. So let's see what. All right, botnet in action. We're being lazy today? God damn it. We practiced this.
Let me to wrap it up correctly.
Okay. Red team testing is one aspect of this, where we're using it, where other people are starting to use this, looking more carefully into those channels. Okay, and you will find, not you can find, you will find stuff that will make the hair in the back of your neck just go boop. Scary stuff. Botnets in no internet or closed networks. I mentioned before, especially, and we're going to see that in the data exfiltration technique, ways to communicate outside of non-networked networks, if it makes sense. Basically, high security networks that are fully disconnected and air-gapped from the internet or from other networks. Okay? If you see voice over IP somewhere in there, just to facilitate internal communications or just phones, you can get out. Okay? And you can have a lot of fun there. And the last thing is botnets for voice over IP phones. Okay? We're starting to get smarter and smarter phones. They're not there yet, but it's, you know, it's an attempt. And these things actually start to run SIP and voice over IP. And they're powerful enough to be considered as PCs that are worthy to participate in a botnet. Okay? We're connected to high-speed networks, 3G, often Wi-Fi. Why not use them as part of the botnet that does DDoS or whatever it is? Are you okay now?
Yeah, I'm great, thanks. Okay, so we're going to see how exactly this VoIP botnet can actually be implemented. So the first thing we have to keep in mind is we're looking on the telephony system, which has not been changed in the recent years, and basically have two ways to communicate. We can either have the bot master calling each of the bots individually and send them commands. That would be a very ideal channel for a private conversation, but again, since the botnet will grow larger and larger, the task to maintain these phone numbers, these identifiers of the bots, is harder. So the unicast method would not work for this kind of botnet. What we're going to try to do is to create a similar to an IRC channel feel over the telephony system, and we're going to use it during a conference call concept. So a conference call is a very simple concept. Basically, you call in, you get to participate in a conference with other people, and whatever you're saying, they can hear, and vice versa. This is a very ideal IRC-style channel over VoIP. Basically, we have a conference call. Conference call can have a PSTN connection, which means you can call it from a payphone, your mobile phone. So basically, you have a way to get in. It's also accessible, some conference calls, through pure SIP. This means you can have a pure TCP/IP connection to the conference call, and at the same time have a person using a payphone somewhere in New Jersey. So it's a very ideal infrastructure, and you're going to use it today to emphasize the VoIP botnet. So this is an example of a very simplistic conference call. You can see the bots are dialing to the conference call. They could either dial through SIP, or they can actually have other access to the conference call. And the bot master, as you can see below, he can either use a payphone, a throwaway cell phone, or he can actually use SIP as well to get on the call. So like I mentioned before, the interesting concept about VoIP is that they actually bridge together two different entities. We have the PSTN, the telephone network, which is like the internet. It's external, and many people can get into it and from it. And then we have the internet with it. So basically, both the bot and the bot master has to make a choice, and they can use either PSTN to call the bridge and get online, or use the TCP/IP option. The most interesting idea over here, and we're going to get to it a little bit later on, is that we're going to use only technology. I mean, if you're going to use the PSTN, and we're going to claim that you can operate a botnet using a payphone in New Jersey, we're also going to stick into telephony-style technology, which means it will be accessible, and the botmaster could control the botnet using a standard phone. And that's a very interesting thing that we're going to see later on. So basically, all the demos we're going to present has already been, it's not theoretically demos, are practical. And you can, of course, download your copy right now. Mushi Mushi is actually hello in Japanese, and it's basically the botnet that we're going to demonstrate today. The interesting stuff about how Mushi Mushi works is it's going to use SIP as the VoIP protocol. But again, it's not limited to SIP. It's just for the ease of use. We're going to use DTMF tones for input. Again, to emphasize that even if you make the call through PSTN and you have no internet connection and it's a pure telephony system, you can still communicate with your bot and get it to do what you want to do. And of course, since the telephony system is not visual, the bot cannot per se give you an image of the information or have it displayed to you in a very convenient way. We're going to use text-to-speech engines as an output method. So basically, we're going to punch some numbers, and the bot is going to speak back to us. Okay, so DTMF is just one of the ways that you can communicate over the phones. The reason why we choose DTMF is because it's a standard. It means that you don't have to do any predefined negotiation. It will work from my phone, your phone, the payphone outside, and etc. This means that actually the bot can be communicated with from any phone that has DTMF tones in it. This is a very interesting feature, and in early conversation and debates, we also had people asking whether the bot can use DTMF to respond back. Well, the answer is yes, the bot could use DTMF to respond to the botmaster. However, that's not going to be graphically visualized on the botmaster phone. So he will have to use a special software to decode it back. Now, I know on iPhone and Android, there's tons of software like that, apps that do it for you. But then again, it's not generic and it won't work from a payphone. But yes, it is possible to do DTMF both ways. Much like Ian said, we're going to show the demos. We're going to have like a two-letter setup over here. Ian's computer is going to be the actual PBX, which I'm going to dial to, and my computer is going to be the actual infected bot. Now, again, like Ian said, there's a very interesting thing about the VoIP is you can get it instantly up and running in a matter of minutes. We actually did it the same way. We didn't take the time to study asterisks or design our own PBX. We simply went and get the first thing that supposedly worked in 5 minutes, and it is working in 5 minutes, so we're cool with that. What you have to know if you're going to build your own conference call, you're not going to use an existing one, is that you have to pass the DTMF to the other participants. Now, normally in a conference call, if you ever have to experience that, whether you punch up numbers, it's actually a command for your user. For instance, you can mute yourself, you can skip another conference call, and etc. So per se, DTMF won't rely to other participants unless you're going to configure it that way. So for our demos, we're using Asterisk now Linux distribution, and to have the DTMF relying to other participants, we just added the extensions.conf and added the F in the meet me options. The meet me is the conference call bridge for Asterisk. If you're going to use a commercial conference call or any other conference call that you have in mind, check out for this feature. You have to configure it in order to get the bot running. So the idea that we're going to present first is how to use the DTMF passing. Like I said, it's going to be a very simple demo. Basically, the bot master is going to dial a DTMF sequence to the conference call, and the conference call in its turn is going to relay it to all the bots on the line. So basically, the bot master communicates once, and all the bots hears his command. Some misconception about DTMF is since it's very limited or very poorly designed, it's not as good as any other language, or is it limited in some way? Well, the truth is it's not limited in any other way. You can go wild with it and create your own languages and your own syntax. This is like a quick example of what we did in Mushi Mushi. So basically, we have like a grammar that we have asterisks at the end of line, a hash bound as a delimiter, And then we can use examples like 0 pound asterisk, which just mean invoke the command 0 without no arguments. You can do 1 pound, 1 to 3 pound asterisk, which is like invoke command number 1 with the argument 1 to 3, and etc. So basically, you're not limited in any other way, and you can develop it into much more sophisticated language. For the proof of concept and for just to show the capabilities, it's good enough. Okay, so we're gonna try to do the demo. So we have 2 ways to do the demo. The first one is going to be through a mobile phone. Basically, I'm going to connect to the PBX, and Ian is gonna call in through a landline, and is going to activate a simple application on my PC.
If it works.
Yeah, if it's not, we have a backup for it. So.
Just made a small change. Should be fine.
You are currently the only person in this conference.
Alright, so I'm on the conference.
Okay, I'm gonna dial in right now. And fuck, I'm not connected.
Are you connected to DEFCON network? Come on. You should know better.
Something is wrong about your Wi-Fi, man. Something's terribly wrong.
Something went terribly wrong is our IVR intro, because we couldn't. Is our IVR intro
Okay,
because we couldn't find the standard one. You're in?
Yep.
Doesn't feel like it.
Let me try to drop off the call and try again.
All right, let's try again. Just a second.
Okay. The start job.
1 minute. All right, let's try again.
Got it. I mean,
I'm not going to do that again.
There is currently one other participant in the conference.
oh, come on.
Catch it.
Yeah, so by now the bot should be analyzing the DTMF tones to actually see the commands coming, but it's not working for some reason,
Really
so
clicky with
you want to try
this.
again, or we're going to go to the backup?
Let's try one more time.
Yeah, we'll give it one more shot, and then we have like the soft phone PB, the soft phone demo, which
The soft one works.
yeah. Okay. Sorry?
It's enabled.
No, it's enabled. It's enabled. It's actually working.
You are currently the only person in this conference.
Let me get. Wait.
Ended.
I mean. Oh wait, that was supposed to be 0. Ah, shit. Okay, okay. Seriously. Okay, so we kind of jumped to the second demo right now, but we're going to do like a step back and going to show the first one. Oh, come on. You worked before.
Try again. Disconnect.
Yeah. No, 1-0. Everything is
I
echo.
did 1-0.
No.
Try
Yeah,
again.
that's the problem with live demos.
One last.
Yeah, we're going to do it FS. Okay, so right about now, X size should pop up in my left corner of the screen. Here we go.
All right.
I hope you guys saw it because we're not going to do it again.
It's the best use for a BlackBerry, by the way.
Yeah.
It's the only thing it's good for.
So basically, what we saw right now is Ian used, we had the PBX with a DAD line in Vegas. Ian just called in, and I connected through the C protocol to Ian's computer, to the PBX, and he just ran a command, the DTF command, and it popped up XIs. For the second demo, which we actually prematurely showed it to you, is basically we're going to do a ping. Just to show that again, you can do, you can pass arguments to the bot. It's not limited to like a one-way straight commands. So we're going to try to pull that off through the phone. If it's not, we're going to do our own soft phone demo, which is again using the same concept.
One.
Okay. Say, wait. Submit. FS. Submit. I think somebody got dropped off the call. Can we try again real quick?
You dropped.
I did not drop off the call. Come on, try again.
Are you in? Too fast, too slow?
Yeah, I think the line quality is really bad because somewhere along the way we're gonna lose the DTMF.
Oh, it says AT&T here.
Okay, so
Soft.
yeah, we're gonna move to the soft demo, which basically
I got it. No, don't.
you want to do it from okay. So basically, Ian is gonna call the PBX using a soft phone, so it's gonna be SIP directly to the PBX, and I'm connected to the bot through SIP to Ian's computer. I don't see rejection. Come on,
You good?
nothing shows. No.
Okay. You want to do yours?
Okay, let's try to do mine.
We're showing some faith. Kind of worked. Well, it worked the first time.
Yeah.
The gist of the demos are basically, you can do everything. Okay, it's a question of how do you design your language, as Isaac said before, to respond to DTMF commands. So 0 was popping eyes. It could have been, initiate a DDoS on some predefined address. I can chain commands. I can provide parameters that ping that will work. That will work. You can basically punch in any IP that you want. So again, you can walk around, jump into Hooters, get bad service. All right, Hooters.com, and it's done.
Okay.
You good?
Yeah.
All right.
What the? Okay, so it's working from a landline, but it's not working from the soft version.
Awesome.
Yeah. Okay. So
You connected to mine?
yeah, I'm connected to it. So I'm gonna try to shut off mine. Want to do your demo?
Okay. While Isaac is setting up another VM with asterisk, we're going to switch over and do a quick talk a little bit about data exfiltration, which is the second part of what we discussed before. So, data exfiltration. the reason or the research that started this whole thing basically started in the red team, where the situation was very simple. We could break into a network, right? That's not a problem. Drop a USB, talk to someone. You know the drill, all right? There are like a gazillion talks here about breaking into networks. That's fine. The problem was that that network was basically air-gapped. No connection. The whole facility is fenced and barbed wired and whatever you want. And you need to get data out to show the risk, to show that it's possible, and to start working on mitigations and monitoring for voice over IP channels. What the? That's you? So the deal was very simple. We figured, you know what? We saw while doing the recon and intelligence gathering that we had a voice over IP accessible inside that network. Right? There were a few soft phones that were needed for some reason, and the rest was just handsets, which meant that the computer network was overlapped with the voice over IP network, which meant that our payload could talk to the voice over IP network. So the deal was very simple. What we wanted to do is to take the binary data that we wanted to exfiltrate. In that case, it was a few Word documents that were like classified or whatever it is, and basically modulate them to audio. We took half bytes, right, 16 bits, and each half byte was translated to one of 16 different octaves within the human audible range of 200 hertz to 2000 hertz. We generated a tone corresponding to that octave using the payload. The octaves were spread out evenly enough to be easily detected or identified later on, and we'll talk about it in a second, and basically recorded a half-second tone of that octave. Marrying up all those different tones, you basically transcode any binary file to music, to tones. So the demo that we're going to show you here is very simple. We have a proof of concept code written in Python, which is very optimistic and very simple, and is not really designed to be used to actually do this. It's a proof of concept, okay? The main issues with the proof of concept is that it's using only 16 octaves. You can easily use 32 and just transcode whole bytes one at a time. You can shorten the length of every tone, so you don't spend half a second just generating it. And basically, you can take the Linux soft modem driver and get all those hints from old school gangster modem stuff to compress and transcode your data more efficiently over audio. So here we go. Proof of concept is called, first of all, we have a message, all right? In this case, it's message.txt, some secret files, blah, 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 blah. The Python script is data to sound. We're taking an input of message.txt and an output of sound.wave. We're assuring that the file that we just generated is indeed a RIF, a wave file, and we dial out. We dial out to a voicemail. In this case, and my usual preference is Google Voice, because you can get on email when you have a voicemail, and you can get an MP3 of that voicemail. It's just super easy to use. So that was message.wave. At that point, we've got some music playing in our voicemail. We download that MP3, transform it to wave because my Python skills don't allow me to use MP3s. Oh, fuck. And We have another script. This is our VM is voicemail.wave. It is a riff. The second part of the proof of concept is basically sound to data with an input of vm.wave, an output of output.file. We see that the file type is indeed ASCII, just the one we sent, and secrets. Docs that.
All right, so we have the demo ready for the rest of the Mashi botnet. So basically, again, I'm gonna call the conference call, and I'm already on it here. Wow. Can you put the?
Why do you have two holes?
Good question.
That's what she says.
True story. All right, so we're going to dial the conference call. We're going to use this lovely soft phone to show how we're going to do more than just a one-time command. So basically, I'm going to ping a computer using just DTMF tones. So that's a really quick way if somebody was thinking about an out-of-service and whether it's possible over using via botnets.
It's network problem tracking.
Yeah. Really? Thank you. Oh, yeah. Yeah, that's not going to work. Okay, so so far we only did the bot, the master to the bot, and now we're going to do some reverse traffic. We're going to do reading out of information. Of course, one of the things that the bot master would like to do is to get information outside of the computer network that he has access to it. And like we said before, the telephony system does not provide a good visual way to communicate that. So we're going to do the text-to-speech engine trick right now. So basically, this is a very simple trick I'm going to do. Plain out picking up the root entry and my etc password. Again, I'm going to already dial to the conference call. So my computer is going to read out this line in a few minutes.
System administrator /mark/root/bin/sh.
Yeah, so that was a quick way to get a sentence out of the computer. Again, using only the phone, only DTMF, no other software involved. Okay, so we're a bit short in time, so we're gonna go back to the best demo that we're going to show you right now. So basically, we say it's possible to do a one line, but if we'd like to do something more, like to take an entire file outside, it's also possible. Basically, we have this very top secret document. As you can see, highly sensitive and confidential. And basically what we're going to do, we're going to ask the bot to read out, to take this Word file, to convert it to text and read it back to us. I'll do that.
Secret. Some company statement for 2011. We made a $Y million and we're expected to do X more dollars. Next year. DEFCON 19 rocks! Exclamation.
Thank you. So we're going to do a quick jump back to the presentation just to go over some of the theoretical stuff with the time that we have left, and we will take questions, of course, later. So we saw the DTMF demo, and we got the idea that DTMF could be a very good way, a common way to communicate with any VoIP botnet. We saw that text-to-speech could be an ideal data leakage concept. Basically, if you cannot see the data, the bot can read you back the data. We saw Ian in this concept of using the voicemail as a callback. Basically, the bot calls the voicemail, drops the message. No. The ultimate idea that we think that the VoIP botnet could provide eventually is to basically create a VPN. And how the VPN will be created? By simply bringing some seriously old school shit back to the game. Bringing back the modem, HDLC, and PPP protocols. Basically, we can have the idea that the bot will create a VPN, will call back to the master, and will get an IP. And in that way, you can see it's similar to a VPN. All the blue dots are basically what's going to be on the public infrastructure, and all the red dots could be another layer of communication. And that's going to work with hardware modem, software modem. It works within the voice frequency. It worked in the past. It will work now. Works under poor connectivity issues, and of course it's a two-way communication. So basically, if you look at the last bullets, the bot master can simply explore his bot. He can then use protocols such as IRC, HTTP, and whatever else he wants. He has an IP access within the organization, and he can do whatever he wants with it. So just to conclude, what you guys heard today is that the VoIP botnet is as good as any other botnets out there. It's not less of or bigger than HTTP. Every communication protocol has its pros and cons, but we believe that the VoIP has much more pros in it, and therefore we suspect it's going to be, if it's not already been used, it's going to be probably used in the future. And it's something that the industry needs to think of. It's something that your company needs to think of the next time someone says, oh, we can save a lot of money by implementing this technology, and it's cool, and it's fast, and it's easy. But then again, there is no controllers, there is no awareness, there is no help to understand what actually can happen. That's kind of the result. A word about the countermeasures. So yeah, the first thing will be to separate the VoIP network from the corporate network. I know it's tempting to have a soft phone in your computer and have the ability to go on and off with it. But again, the risk is that if there's a VoIP infrastructure that comes all the way from a payphone to New Jersey to your computer, then this is a risk that you have to think of over the advantage of having a soft phone installed. Definitely monitor the VoIP activity. That's something that people don't do, and like Ian said, we do it for web, we do it for emails, we do it for what else, but for VoIP, it's like, psh, it's going to be okay, no worries about it. And that's the problem. And the last bullet is kind of experimental thought. It's if your company or yourself are using some very specific conference calls bridge, so there is actually no reason for anyone else to connect to a foreign conference call for that matter. So again, although it's not going to solve the problem, it could be a way toward the solution, just to have a better understanding of auditing your bills and allowing which numbers can be made calls to. How's the future going to be? Well, the future is going to be very soundish. It's going to be speech to text as an input. Again, today we emphasize the DTMF as an input vector. Again, in the future it could be commands spoken by, do that, give me that, attack this. It's capable. We have the mobile angle, which basically going through SMS gateways and basically get visual appearance. The bot can text you, you can text him back. And some of the going back, basically one way to get a screenshot, which is a very interesting vector, is basically have the bot taking a screenshot and then communicate it as a fax. So you can basically have a screenshot of the computer that you're looking at through the fax. And of course, for the internal VPN style communication, bringing back the modern protocols and these protocol communication. That's about it.
That's it. Let's go.